Okay, let's talk about seasons on a globe. Now, we were taught this like when we were kids, right? So let's take a better look at it. Okay, here's our miniature globe model, and I'm going to show you how the seasons work. So this is our summertime where the globe is tilted towards the sun for the summer solstice. And we're going to be talking about Michigan because Michigan's a nice moderate spot to use to show what we're trying to show you. So now the Earth spins for days. That's how you get your day and night. And then at 3 months later, which would be about here, this is the equinox. So it's going to start getting colder because the angle is changing. And 3 months later, which would be 6 months later from the summer, now the Michigan's tipped away from the sun, and that's how you get wintertime. Okay, in this video, we're going to be talking about Michigan. And if it's possible, the angle of the Earth is going to make that type of difference in temperature from the winter to summer. Okay, so here's Michigan right here. Now you can see it's tilted. This is summer solstice. It's tilted towards the sun. And Michigan hangs over the equator like, let's say 1,000 miles roughly. Now in the wintertime, we're going to flip it around the other way. Okay, now Michigan is going to be right here basically. It's going to be, let's say 3,000 miles in. So there's a difference of like 4,000 miles between winter and summer as far as the distance to the sun goes. Now let's look at the distance to the sun. The sun is 93 million miles away, and at a 4,000 mile difference, take 4,000 divided by 93 million, and you get 0.00004, which is really, heat-wise, I imagine it would be negligible. Okay, let's tilt the globe away from the sun. Now, one of the ways we can get an idea is let's say we'll take the coldest day in the wintertime at noon, and then we're going to compare it to, move this back to summertime. We're going to compare it to morning. Here's Michigan. We're going to compare that to morning in the summertime and see what the temperature difference is to see if our angle makes a difference or not. Here's our sun shining on the globe in the wintertime model versus summertime. Okay, so here is, I'm going to use a stick right here. I don't know if you can see it. Like there's a middle of Michigan. We're doing Michigan because it's out of 40s. It's at like the 44th parallel. So here's our stick, measuring stick. And let's see what the temperature is. First, let's touch the 75 degrees at 5:22. 91. 90. Okay, so let's wait 10 minutes. Okay, we're back. It's probably about 5 minutes went by. I don't know if I got to use a measuring stick every time so you guys can see, but I guess you guys are going to have to trust me a little bit here. Okay, so I'm doing David Weiss's theories. This is wintertime. See the angle? This is wintertime. Angle in a way, 23.4 degrees. Okay, 75 degrees still. 5 minutes later. There's Michigan. Right there. Now it looks like the temperature's still going up, so let's wait another 5 minutes. Okay, it's a few minutes later. 75 degrees. 4 minutes later. Okay, let's test Michigan here. Yeah, 92, almost 93. So it looks like it stopped at 93, 92 and a half. I don't know how well you can see this, but I made a little protractor. Probably see it better. I made a little protractor to line it up with a string to the center of the heat lamp. So when we do summertime, we're going to try to do the same thing. Oh, doesn't come out that good on. There you go. See? Okay, let's switch it around to summertime. Get up. Now we got it facing towards the globe, towards the sun. And let's check our temperature. Let me get it set up. Okay, summertime. Let's check our angle over here. So you get the idea. I did it better in real versus on the camera. And then the length, here to here, it's basically the same. Okay, it's a half hour later. The temperature went up 0.2 degrees in the room. I don't think that's a big deal. So let's see where we're at right now. Oh, right there. Okay, 3 degrees. Let's come back a little bit and see what happens. Okay, so here we are 20 minutes later. It's still 75.2 degrees. And I was here 10 minutes earlier. It was 88 degrees. So let's see where it is now. 87. So it looks like it's maxed out now. 87, 88 degrees. Actually, I thought the numbers were going to be pretty close to identical. And how can it be that in the morning in the summertime, it's actually cooler than in the wintertime at noon? It doesn't make any sense, right? Okay, just for fun, let's take a look at the hottest day of the year. Okay, now we got to tip forward. And we're going to use our measuring stick again. Let's see. So you can see from Michigan, it's pretty close. Yep, it's like really close. Really close. Okay, let's look at 74.5 degrees this time. So it's a half a degree lower than last time, which isn't much. Let's get our initial reading here. Okay, we're on Michigan. It's 88 degrees. Let's come back in a few minutes. Okay, 74.6 degrees, 3 minutes later. Let's take a look. 92 degrees, 91 degrees. Okay, let's see if it still goes up. Okay, it's another minute later. Let's take a look. Michigan, right there. 92, 91. Let's see if we're bottomed out. Come back in 2 more minutes. Okay, another minute later. And let's see if the temperature topped out. 92 was last time, I think. Right on Michigan, 93. Oh my God, it's almost 92, 93, 92 and a half. So it looks like it topped out. Basically, 91 and a half. I had 92 a second ago. It's basically it's basically the same as wintertime, which doesn't make no sense, which explains the angle doesn't make a difference. The distance makes a difference. Let me show you what does make sense. Standard map of the world, patented 1892. Flat Earth map. This is how the sun works in the wintertime. This is how the sun works in the summertime. If you're in the northern hemisphere, here's the sun goes around in the inner ring in the summertime, and then it goes on the outer ring in the wintertime. And that's how the sun works on a flat and stationary Earth. Okay, so here is Michigan, right there. Here's the sun. In the summertime, the sun is close to Michigan. It's making a tight circle. In the wintertime, it's making a farther circle from Michigan. The sun is farther from Michigan, so it's colder. Pretty simple. They say that a planet hit the Earth and caused it to go on its tilt. Now, if you were going to fake the globe, why would you make the tilt 23.4 degrees? That's because from the equinox to the summer solstice and the equinox from the winter solstice is 23.4 degrees.